In the previous sessions, we understood that matter is made up of particles and the particles of matter have certain characteristics, correct? And now in this session, we will try to understand why matter actually exists in different forms. And in understanding that, we will make a comparative study between two substances, okay? One substance is, I will take an iron cube, okay? And the other substance I would take is a beaker in which water is filled in. Okay. Now, if you look at these two substances, do you think are these two substances one and the same? No, correct. They don't look same and they don't behave also similar, correct? Because if I'm taking this iron, I'm able to hold it in my hand. But whereas I take water, if I try to pour it into my hand, it will just flow away from my hand. But whereas I can hold this in a beaker in which it is placed in, correct? This actually tells me that these two substances are different. Then the question here is, why are they different? So they are different because the iron is made up of iron particles, whereas water is made up of water particles. So now here both are made up of particles, correct? If they are made up of particles, then that means that they should have certain characteristics. So in understanding these characteristics, these two have same characteristics, but the magnitude of those characteristics is different. How come? Let's try to understand it better. Okay, if I'm taking the first characteristic of matter, that is the particles of matter, attract each other. Okay, so we understood that the particles of matter attract each other. So this is matter, this is matter. So here the question is, are they attracting each other is the question. So to understand this better, let's go back to the previous sessions where we analyzed that it is very easy to cut water that is present in the pool through your hand, correct? So because you apply less amount of force, you cut it through your hand and still pick the water into your hands and the water is still intact in your hands. The reason is the particles of matter attract each other. That is the reason why you are able to hold this water together, and at the same time you are able to cut through water because the force that is needed to cut that water is very less. Correct? But for example, now suppose I have a big sheet of iron. Okay, and now if I ask you to cut through iron with your hand, will you able to cut that iron through your hand? No, right? It is really difficult. Why do you think it is really difficult to cut through iron? Because the particles that are present inside the iron are very strongly attracted to one another compared to that of the water. So this tells me that, the iron particles present in iron are attracted more towards one another compared to that of the water. Correct? So if I'm making a comparative study here, there is more attraction between the particles of iron, whereas here it is less attraction between the particles of water. Correct? So this first characteristic explains me that why these substances exist in this manner. Because of this attraction, what happens is the particles are so close to one another. So this tells me that the space between the particles of matter is less in iron. Here it is more, because the attraction is more, hence the space is less, and here attraction is less, hence the space is more. Do you understand this? And in understanding this, I would like to ask you something. If there is a diffusion between iron and iron happening, and if there is a diffusion between water and different particles happening, in which case do you think the diffusion would be better? So we know that diffusion depends on two things. One is the kinetic energy of the particles that make up this particular matter, And the second thing is into which medium they are diffusing into. Here, if the iron is diffusing into iron, so I have two pieces of metal cubes of iron. Do you think this iron metal cube could diffuse into that iron metal cube? No. Why is it not possible? One thing is the particles of matter are actually have less space between them. That means the medium into which it is diffusing has very less space. But whereas here in water, the particle to particle space is more. Hence, if I add water to water, it will the particles of this particular sample A would diffuse into this particle B, correct? Because they have more space. So this is something that we could explain in terms of medium. And also we know that we have to explain that in terms of kinetic energy of the particles. In understanding the kinetic energy of the particles, let's take a closer look here. We know that particles of matter are continuously moving. Okay. So if they are continuously moving, okay, there is more space. So there is a probability that they can actually move between particle to particle. And that is actually true in terms of water. But then how about in terms of solids? Solids look so stable and so, compact. They have a proper definite shape. If you look at the cube, this has a very well defined definite shape and also well defined volume. If I place the cube in this hand, it will occupy the same volume in space. And if I take the cube and put it in this hand, it will still occupy the same volume in space. So the volume of the substance here, it is defined. Correct? So that means, how are the particles of iron moving then? There is something known as vibrational motion. The particles of iron are moving, but by very less extent. That means they are just vibrating in their places. So the motion is so less that they are just only vibrating. You understand? So here the motion is present. The motion is vibrational motion. But here the motion is more compared to that of the iron particles because there is have more space between those particles. You understand this? So this tells me that the medium in water have more space, and similarly the particles of water have better kinetic energy compared to that of the iron. Hence they are actually moving better compared to that of the iron. Because why do they have more energy? Kinetic energy here is, if you look at the particles of water, they are less attracted to one another. Hence the attractive force between them is very less. So less amount of energy is required for them to just move. But whereas in terms of iron, if they have to get more kinetic energy, firstly they have to overcome this attractive forces between the particles of matter. Hence in iron you see less kinetic energy of the particles compared to that of the water. So this tells us that the diffusion of particles in solid and solid are really difficult, but whereas in water to water it is easier. Correct? And now in understanding this cube, I would like to ask you one more question. Do you think this iron has a definite shape and a definite volume? Yes, as we discussed, they have a definite shape and they also occupy a definite volume. Correct? And the other thing I would like to know is, if I'm taking this iron, do you think I'll be able to compress this iron just through my hand or by applying some huge external force? It is very difficult to compress, correct? So that is the reason if you look at a lot of videos, if you want to crush this iron cube, if you want to compress this iron cube, they will be using some very big hammers to actually hit this iron to actually even break. They are really difficult to compress and they are really difficult to break. You understand? Even if you break them, what happens is they will become into two pieces, but still they will not lose their shape. You understand? So this tells us that the iron has certain characteristics, that is they have definite shape, definite volume, and they cannot diffuse into one another, and the compressibility of the substances is very less. The reason why they are not compressible is because of the very close arrangement of the particles. You understand? Very close arrangement of the particles, hence their compressibility is very less, and the particles are arranged very close to one another, hence they are rigid. You understand? If there is any substance which have similar properties to that of iron, then the substance we is known as a solid. Okay, now we can tell that solids are different substances with different properties, and the properties of solids are different because of the characteristics of particles of matter. So when we told that water is different from iron, we are seeing these differences. So we can say that iron is a substance which have different properties. Hence, this type of substances are known as solids. So in explaining this, let's take one more example. Let's take a chalk piece that is in my hand. Now, may I call this substance a solid or not? First, let's try to check all the, properties that are needed for a solid. First thing, do you think it has a definite shape? Yes, it looks a cylindrical shape to me. It has a well-defined shape. Correct. And the second thing is the volume. If I place it in my hand, this has a volume that is occupying some same space, that is some cylindrical space in the air. Whereas if I'm placing it here, here also I feel that this have the same shape and definite volume because it is occupying the same space. You understand that? So this tells me that the chalk has definite shape and definite volume. First thing. And do you think it is easy to compress this particular chalk? Trust me, it is very difficult to compress this particular chalk because the particles inside this chalk are very closely arranged to one another. Do you understand this? And the other thing, just because they are closely arranged to one another, this tells me that the only way they can get, they are arranged very close to one another if the particles of matter are actually attracting one another. You understand this? So we understood this, the particles of matter in this chalk are attracting one another, and the space between the particles is also very less. That is the reason this has a definite shape. You understand this? And the particles that are present in this chalk are actually vibrating. You understand? And this tells me that, the substance that I see in front of my eyes is also a solid, just like iron. So in understanding this, let's try to take few more examples. Okay, let's take a rubber band. So have you seen a rubber band? Okay, if you we have just told that solids have definite shapes, correct? If they have a definite shape, if I apply some force onto this rubber band, they lose their shape, right? Initially the shape would be just like this much, but when I applied some force on both the sides, it was stretching to this big. Now here the question is the rubber band is solid or not? The rubber band is a solid. So when I not apply any force, I will see that lying in my hand and it exists as a solid with a definite shape and definite volume. But when I try to stretch it, what am I doing is I'm applying some force onto this rubber band. So this force, because of this, the particles inside that rubber band has the ability to actually stretch. Hence what they do is they stretch as I apply some force. But if I apply enough amount of force, then they could overcome the attraction between the particle to particle that is present inside this rubber band, and they could actually break, just like your chalk paste that we have discussed in the previous sessions. If I apply enough amount of force, then they would break easily. You understand this? That is the reason you say that rubber band is a solid, but just because of the characteristics of the particles, that is, they can actually stretch to certain extent until and unless there is a force that could overcome the attractive force between the particle of that rubber band and the other particle of that rubber band. That is the reason they stretch and then they break if more amount of force is applied. You understand? And we can say that this rubber band is a solid and it still attains its original shape once the force is actually released. Okay, and the second example we will try to understand is that they have definite shape. Okay, when they have definite shape, if I'm taking some sugar crystals or salt crystals and I'm putting it into some some box, So what will happen to the sugar crystals or salt crystals? They take the shape of that box, correct? If I'm putting it in a cylindrical box, they take the shape of a cylindrical box. If I'm putting it in a spherical box, they take the shape of a spherical box. Here we are saying that the solids have well-defined shape. But if you look here, they are taking the shape of the container. That means here the shape is different and here also the shape is different. Does it mean that these two are not solids? The salt and sugar are not solids? No, we are talking about sugar. See, sugars are crystals, whereas salt is also a crystal. So when you look at the crystals of the salt or sugar, you place them in any container and you place them in your hand, whatever is the shape of the crystal of sugar, it would be the same even though you place it inside the container. You understand? So this tells us that the shape of the sugar is not actually changing. It has a definite shape and a definite volume. Do you understand this? So hence I can tell that the sugar and salt are actually solids. Okay. And the second thing, have you ever observed sponge? So if you are taking the sponge in your hand, if you press it, will you be able to compress it? Why do you think that compression is happening? So that means if I'm able to compress it very easily, then sponge should be regarded as not a solid. It should never be a solid because it is compressible. Do you think it is true? See, let me tell you something. The sponge is made up of a solid, but the thing here is inside the sponge there is some air holes that are present. Because of those air holes, we know that the solids are not compressible, but there is air present in it, and this air, when you press this air, the air is coming out of those holes. Because of that, you feel that you are actually compressing the solid sponge, but you are actually compressing the air. So this actually tells us that air is compressible because actually you are able to compress this solid, whereas this air is moving out of those particular solids. If it is not compressible, then the holes in which the air is present should hold just like that of the iron that you see. Correct. This also tells us that air is actually compressible. You can compress it. But when you look at this sponge, it is compressible. The only reason is because of the holes present in the sponge. And have you observed, after compressing, after taking out all the air, you end up holding it in just a very slight volume. After that, do you think it is easy to compress after that also? No, as you compress it, it becomes very difficult to compress even more. The reason is that the air holes that are actually present in the sponge now are actually closed, and now it is forming a solid mass. Hence, it becomes difficult as you try to compress the sponge. It becomes very difficult to compress the sponge even more. Do you understand this? So this tells us that the solids are defined by certain properties, and the properties of a solid can actually be defined by the characteristics of the particles of matter. Okay, now in this session we understood that solids have certain properties. One is they have definite shape, they have definite volume, they are not compressible and they cannot diffuse into one another, and they are also very rigid. Okay, thank you so much, and I'll see you in the next session.